going to do a couple examples of exponential equations. This is similar to number 743 in the textbook. Now, an exponential equation would be something like this. 3 squared equals 3 to the x. I bet you guys could figure out what x equals here. Because the bases are the same bases, the tops, these exponents have to be the same. So we're going to have x equals 2. Because these guys are the same, we can cancel them out. So 2 equals x. And we can check our work. 3 squared is 9. 3 squared is 9. So we're okay. Now, a couple things I want you to keep in mind is the bases have to be the same. If they're not the same, we're going to have to hopefully make them the same. So let's try this one. 3 to the x plus 2 equals 9 to the 2x minus 3. Now before you go too far and say, oh no, they're not the same bases, I can make this 9 look like a 3 because, just like over here, 3 squared is 9. So I'm going to substitute that right here. So I'm going to say this, 3x plus 2 equals 3 squared. So this just got brought down. And this 9 is 3 squared. Okay, so now my bases are the same. We can continue on. I can ignore the bases. Then I have 2 times that. So I have x plus 2 equals 2x minus 3. X plus 2 equals 4x minus 6. Let's go ahead and simplify this. Let's take x from both sides. I'm going to add 6, 8 equals 3x. X equals 8 divided by 3. Okay? So the trick here is this first step right here. We have to have our bases the same. Once the bases are same, we're good to go. Let's try a handful more of these. How about this one? 4 to the 3 plus x equals 25. Can we solve that? No. With the math we know right now, we cannot solve this equation. But we give it a stab at it. Let's see. So I know 4 is 2 squared, and 25 is 5 squared. Well, 2 and 5 are clearly different bases. In advanced math, we can go ahead and solve this using logarithms, but with what we know today, we cannot. Okay, let's give another one up here. How about 2 to the x squared times 2 to the 3x equals 16. Okay. Base is the same. Base is the same, base is not the same, but I can make this base the same. I know 16 is 2 to the 4th. So 2 to the x squared times 2 to the 3x equals 2 to the 4th. Okay, those guys are equal. Now my bases are the same. Now we're a little different here. What do I do with exponents? Bases are the same. What do I do with the exponents? I add them. So we're going to have x squared plus 3x equals 4. And let's go ahead and solve this for x. X squared plus 3x minus 4 equals 0. We have a quadratic. This x squared term is a quadratic. So we're going to have to go ahead and factor this out and use the zero product property. X squared, negative 4, like that. So it's going to be x, 4, 4x, and that's going to be 1x. Check our signs. We need a positive and a negative. So let's make this one positive, positive, negative, negative. So my factors of this, this guy gets factored out to x plus 4 times x minus 1 equals 0. Now we can use the zero product property. X plus 4 equals 0, x minus 1 equals 0, x equals negative 4, x equals 1. Okay, I have two answers here. Do both answers work? Are they valid? Let's give it a quick try. So let's try 1 first. I'll go back to my original equation. 2x squared times 2 to the 3x equals 16. Let's try 1. 1 squared is 1, so 2 to the 1. And then 2 cubed, that's 2 times 8, which is 16. So that one works. Let's try negative 4. 2 negative 4 squared times 2, 3 times negative 4 equals 16. Negative 4 squared is going to be 2 to the negative, 2 to the 8th times 2 to the minus 12 is 16. Because these are the same base, I add them. I do not want to try to find 2 to the 8th. I do not want to try 2 to the minus 12. We're going to avoid actually calculating those, but instead we can add them. And let's see, 3 times negative 4 is negative 12. 4 squared, 4 times 4, that's 16, I'm sorry. That's 16. So then I have 2 to the 16 minus 12 is 2 to the 4th, and 2 to the 4th equals 16. Okay. And let's give one more problem a try. How about 1/4 to the x minus 2 equals 8 to the x. Again, the strategy is the bases must be the same. If they're not the same, we do not have the math to solve these. So this is the trick. 1/4 is the same as 4 to the minus 1. I'm going to swap this out to 4 to the minus 1. Then you're going to see the 4 and 8 we can play with. So 4 to the minus 1 times x minus 2 equals 8 to the x. Now we have to deal with this 4 and this 8. So 4 squared is 16. That's not going to help. 2. So I can't really go up, but I can further decompose them down. How about this? 2 squared, because 2 squared is 4. That's going to then be -1 times x minus 2 equals 2 cubed times x. Okay? A little ugly, but it's doable. So the bases are the same. We can ignore those, and we go ahead and simplify this out. I'm going to simplify the inside here, and that's going to be, go like that with it. So we have 2 times -x plus 2 equals 3x. I'm going to do this again. -2x plus 4 equals 3x. -2x%, yep, so plus 2x. 4 equals 5x divided by 5. X equals 4 over 5. I'll let you go ahead and check your work and substitute that in. So, quick little summary. To solve equations that look like this, you must have a common base. Okay, you need the common base. Without a common base, you're not going to be able to solve these with the math we know today.